Hello everyone, welcome to solve this nice math Olympiad algebra problem, and here we have n minus 3 and its whole power 4 equals to n to the power of 4, and we solve this problem for the real values of n. So here you remember one thing is that our n is real, so the very first step we are going to do is here first we rewrite this equation as n minus 3 and its whole power 4, and we move this term in the left hand side, and it will be written as n to the power of 4 equals to 0. And after that here we again rewrite this equation as n minus 3 whole square. So we just break this exponent 4 and we write it as 2 and its whole power 2. So we write this expression as n square and its whole square equals to 0. And after that we use here the nice square identity. You know that if we have x square minus y square, it is equals to x minus y times of x plus y. So you see here n minus 3 whole square is denoted by our x, and this n square is denoted by our y, and we know that this is x square minus y square. So we use here this nice formula according to these terms, and we write it as x minus y. So here our x is n minus 3 whole square, and minus our y is n square, and this is the our first factor. And after that we have x plus y, so our x is n minus 3 whole square and plus y is n square, and this whole equals to 0. So after that here we have two cases. So our first case is we take n minus 3 whole square minus n square equals to 0, and the second case is we write n minus 3 whole square plus n square equals to 0. So we have these two cases, and we call this is equation number 1 and this is equation number 2. So here we solve these two equations one by one and we find the real roots. So that first we focus on case number 1, or first we focus on case number 2. So from 2 we have n minus 3 whole square plus n square equals to 0. So we first open the square of this term and we write it as a square plus b square minus 2 times of a into b and plus n square equals to 0. And after that we rewrite this equation as n square plus 3 square becomes 9, and 2 times of 3 becomes 6n plus n square equals to 0. So after that we add this n square and n square, and we get here 2 times of n square minus 6n plus 9 equals to 0. So here finally we get the nice quadratic equation. So first we check is this quadratic equation has real roots or not by using the discriminant formula. So first we write the coefficients of this equation, and its coefficients are a equals to 2, b equals to minus 6 and c equals to 9, and our discriminant formula is b square minus 4 times of ac. So here we substitute the values of a, b and c here, and we write it as minus 6 square minus 4 times of a is 2 and c is 9. So we get minus 6 square becomes plus 36, and 9 times of 2 is 18, and 18 fours are 72, and 36 minus 72 becomes minus 36. So this shows that our delta is less than 0. So it means that if our delta is less than 0, so this quadratic equation cannot have real roots. So we just write here this equation has no real root. So if this equation has no real root, so that we rejected this case because we need to find only real roots. So now here we focus on equation number 2, equation number 1. So this is first we focus on 2 and now we focus on equation number 1. So here first we copy down this equation and we write it as n minus 3 whole square minus n square equals to 0. So here we use the nice square identity, and this is a square minus b square, so which we use above. So now we again use this identity. So here we again use this identity and we write the output here. So here our n minus 3 is x and this n is over y, so we write it as x minus y. So here our x is n minus 3 minus y is n into x plus y. So n is x is n minus 3 plus y is n, and this whole equals to 0. So here you see that this negative and positive are cancelled by each other and we get minus 3 into n plus n becomes 2n minus 3 equals to 0. So here we divide both of the sides by minus 3 and we easily get here 2n minus 3 equals to 0. So here we move this minus 3 to the right hand side and we get 2n equals to 3, and finally we have the value of n equals to 3 by 2. So this is the real root of the given question, because in the second case we get the complex roots but here we get the real roots. So this is the our final answer, but now here we first check this value of n. Is this value of n satisfied our given question statement or not? So that here we copy down the given question statement, and our given question statement is n minus 3 and its whole power 4 equals to n to the power of 4. And now here we replace this n equals to 3 by 2. It will be written as 3 by 2 minus 3 and its whole power 4 equals to 3 by 2 and its whole power 4. So here we take the LCM and we write it as 2 into 3 minus 6 and its whole power 4 equals to 3 over 2 and its whole power 4. So that here we obtain 3 minus 6 becomes minus 3 over 2 and its whole power 4 equals to 3 over 2 and its whole power 4. So here we know that if you have the negative term and its exponent is even number, so it will become positive. So we write it as 3 over 2 and its whole power 4 equals to 3 over 2 and its whole power 4. So this shows that left hand side equals to right hand side. It means that n equals to 3 over 2 satisfied our given question statement, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.